for long perceived as one of the most polluting industry on the planet, number of paper industry are developing toward more sustainable technique. Let me dwell on the city Trois-Rivières, pulp and paper capital city of Quebec, Canada. With their multiple partners, the company Innofiber managed to build up a real network of experts working toward their ecological footprint reduction. Simon Barnabé, researcher in University of Quebec in Trois-Rivières, is one of the main stakeholders working with Innofiber toward the integration of economy into environment.
On a développé au fil des années une proximité avec les villes, les municipalités. On croit beaucoup que les municipalités, les villes sont au cœur de l'écosystème de recherche et d'innovation, dans le sens qu'ils nous aident à se rapprocher des véritables utilisateurs des résultats de la recherche, c'est-à-dire des citoyens. Oui, on travaille avec des entreprises, par exemple, les entreprises, des employés, c'est des citoyens. Donc, ça nous aide beaucoup à gagner cette fameuse acceptabilité sociale, voire mieux encore, cette désirabilité sociale, tant recherchée pour nos travaux de recherche. Puis en plus, avec cette proximité-là avec les villes, on réussit à se rapprocher davantage des décideurs municipaux et souvent, la science est importante pour eux, puis ils ont beaucoup de difficultés à se l'approprier. Fait qu'en faisant des projets de recherche avec les villes, ça aide beaucoup à rapprocher la science, à instaurer une certaine culture scientifique dans nos villes et leurs décideurs municipaux.
Therefore, many projects were developed, and especially an ambitious one, implementing what they would call a CO2 biopark, including algae, in order to limit the greenhouse gases of one of the most pollutant cement plants in Quebec. Using algae, they estimated that they could already fix 1% of total CO2 emission of the cement plant. For the rest, they will use other CO2 reconversion, conditioning, transformation, and capture techniques that I will not develop here. But before considering a scale-up, the feasibility of producing microalgae in cohabitation with the cement plant need to be assessed, and for that a lot of upstream research work is needed, which leads us to the problematic we wanted to resolve. What would be the effect of photoperiod-like cultivation, so a culture with light and dark phase, and gas exposure on a green microalgae growth and its biomass composition? Hello, my name is Camille Boucaud and I am a master student from Marais doing a project in Innofiber and University of Quebec in Trois-Rivières, Canada, within the team of Simon Barnabé for 4 months. During this project, we chose to work on the microalgae Chlorella sorokiniana because of its generation time that seemed to be the fastest, but also because it has been shown that high CO2 concentration exposure can produce high-value molecule in this algae, which could be one of the gains for the application of algae culture in an industrial park. However, Kumar and al. Also demonstrated that at a certain concentration of CO2, the growth of Chlorella sorokiniana could be negatively impacted, proving the necessity to evaluate the composition of the main gas effluent on the field and its effect on the algae. The main objective we had was to have set and stable culture method as well as condition. Within my project, I work on small volume of 2.5 liter and bigger volume of 300 liter. Next to me, you have an overview of the project process. In both cases, algae concentration over time was daily assessed and algae were sampled every 2 days for further biomass quality and quantity assessment. We perform what we call a photoautotrophic culture, which uses inorganic source of carbon, so CO2. As controlling big volume of culture was too ambitious within a period of 4 months, we decided to test the percentage of CO2 present in the cement plant only for a culture volume of 2.5 liter. Also, I only tested CO2, but other gas present in the industry were already or will be tested. When assessing the biomass, we quantify the lipid content in percent of lipid in total biomass, and these are the main results we obtain. During the experiment, it seemed that the lipid content decreased when CO2 is injected compared to the control. In addition, differences in biomass productivity for the CO2 batches were observed. However, a statistical analysis will need to be performed when all the results will be available to determine whether these differences are significant or not. While cultivating algae in big volume, we face many challenges such as maintaining the culture sterile, harvesting the algae, or even prevent the stress of algae exposure to light at the beginning of the culture. Despite this challenge, it was a real opportunity and a pleasure for me to contribute to industrial research with its moment of frustration, but also its rewarding event when we managed to control a culture, for example. Finally, this project allowed us to gather more data on this microalgae and its biomass composition and to compare it with the other conditions that were previously tested. It's also allowed to produce biomass that will be preserved and further used by the technician of Innofiber for many uses. Yet, additional work will be required to guarantee the scaling up in the industrial park, such as test the effect of gas effluent on high volume, study the CO2 fixation ability, but also the effect of continuous injection of gas, since CO2 was injecting only when pH exceeded 6.7.